Okay, this is May June 13 through 3. And you can see this one state two way in which the boiling differ from evaporation. So you know boiling, what is boiling? Like, so what you write about the boiling? Boiling take place at specific temperature, right? Boiling take place at a specific temperature, but evaporation take place at any temperature. Then what are the other point you can write? Evaporation take place at surface, but boiling take place throughout the water. Okay, throughout the water. uh, Boiling will take throughout the entire water, but the evaporation will take out at the surface. Okay, and it happen evaporation at it happen at any temperature, but the boiling will happen at like 100 Celsius. When the temperature will be 100 Celsius, then the boiling will happen, right? And one more point, you can write evaporation affected by the surface area. Boiling is not affected by the surface area. Okay, explain in terms of water molecule what happened to thermal energy is applied to the water as it boils. Okay, so what happened when the thermal energy, heat energy is applied to the water? What it will do? So what happens here? When the thermal energy is needed to separate what a molecule against force of attraction between water and molecule to break the bond. To break what? To break the bond. And kinetic energy and speed also does not increase now. Okay. First, what will happen? First, the thermal energy will work on breaking the bond between the water, and the molecule will change from the water, like yeah, first it will break the bond. Not don't talk about the change in the state. First, what is the first word is to break the bond between the molecules, between two water molecule. Okay, so what you will write, they might ask you this question: why the temperature of water does not change during the boiling? Why it will not change? Because the energy provided is used to separate the molecule, water molecule. Okay, that is also called force of attraction between the water and molecule. Okay, and also one more point you have to write: kinetic energy and speed also will not increase. Okay, this specific heat of stream, specific latent heat. So for the specific latent heat, you will draw this diagram. I will give you two diagrams. You can draw any diagram. Okay. This is the beaker. This is the balance to measure the mass. This is the thermometer to measure the temperature, and here are some eyes. Okay, and one more glass rod to stir. So you have glass rod to stir, thermometer you have, ice you have, water you have, how much water it changed, and the balance you have. Okay, so here you have to describe First you will write what are the apparatus needed, then you will write what is the procedure. Okay, so here you need balance, you need measuring cylinder, you need thermometer, you need glass rod to stir, and what else you need ice, right? Okay, one more also you can do, this is you need beaker, your funnel, you'll put some ice here, the funnel. Okay, so here this is for latent heat, right? Yes, so these two experiment you can do, and there is big water will drip into it. So what you need power supply, and this is the heater, this is the power supply, this is the beaker. The water will fall. So here what are the apparatus you need heater, you need power supply, you need beaker, right? So the point you write, first turn on the heater and wait until the water start dripping into an empty beaker. And you need a stopwatch. Okay, then start stopwatch and record time taken to melt all ice. Again I'm reviewing, then what you will do, start stopwatch to record the time taken to melt all ice. Then what your third point, what you write, record the mass and liquid in the beaker. Record the mass and liquid in the, so you need a balance too. So you need a balance, right? Too. Okay, again I'm saying what are the things you need beaker, here you need a beaker, you need a funnel, you need okay, you need a funnel, there is the funnel also, let me see, funnel, you need a heater to heat the ice, right? And you need a beaker. Okay, the first one you will turn on the heater and wait until the water start dripping in an empty beaker. Then number two, start the stopwatch and record the time taken to melt all ice. Record the mass of the liquid in the beaker. Using what? Balance. So these are the 3 points you can write. Question 14.3.1. Okay, let me go to the B1. The first one is very easy. Complete the following equivalent statement about the evaporation. A liquid evaporate at what? Okay, it will evaporate at any temperature, right? And during evaporation, what happened? During evaporation, what happened? During evaporation, energetic molecule escape first and leaving the less energetic molecule behind. Without a supply of thermal energy, evaporation without supply of thermal energy, evaporation continue to occur, does not stop. without thermal energy, obviously evaporation will occur, right? It will not stop. You don't have to provide any heat, okay? But the boiling will stop. Once you stop the stove, the boiling will stop, right? The boiling will not continue, but the evaporation will continue. Okay, this one B is, you can see everything is given, just you have to use the formula to do. So time is given 20 minutes. Mass of the water is given 0.075 kg, and latent heat of vaporization is given, okay, that is LB. Calculate the energy used in converting this much, okay. So Q is equal to ml, so you have to calculate Q. M is 0.075, and latent heat of vaporization is given 2.25. just use it, and the answer is 1.7 into 10 raised to 5, okay. So the hot plate operate this much, this voltage is given, current is calculated, the energy supplied to the hot plate in 20 minutes. First you have to change it into each unit. 20, you have to change it into second, right? So 20 into 60, okay. So what is the energy formula you have learned, right? How many energy formula you have learned so far? Like E is equal to PT for electrical energy, then E is equal to IVT, okay. So here we cannot use this one because power is not given, but this is given, IVT, temperature is given, right? This is time, okay, not temperature, sorry, this is time, don't get confused. Okay, okay, so that's why the temperature of B1 and B2 is not same, why this temperature is not same they are asking, why the answer is not same, not the temperature, because energy is transferred to the surrounding, some energy is transferred to the surrounding, right? To the atmosphere, to the air, okay. That's why the energy is not same. Here you got 1.7 into 10 raised to 5, here you got 1.9 into 10 raised to 5 joule. Do not forget to write joule, okay. In 3 2 Major 14, here they are asking define the specific capacity of substances. Unit specific heat capacity, the quantity of heat to rise by 1 Celsius and temperature rise 1 kg unit mass. What quantity of heat to rise by 1 Celsius and temperature rise 1 kg unit mass. Temperature will write how much, 1 kg, and temperature should be 1 Celsius, okay. How much heat is required, so you are just calculating how much heat is required. The specific heat of capacity, how much is quantity of heat required to rise by 1 Celsius and the temperature rise 1 kg unit mass. This is the specific heat. Oh, you can see this one. And so in this question they have given mass, that is in gram, okay, and energy is given and time is given 12 Celsius. So find the specific heat capacity, write the formula. So you have to find C, right? So mass, and this is in gram, so your answer will be in gram. So if you change it into kg, then you will write the answer in kg. Do not forget this. Temperature is 12. Okay, the answer is. So calculate the thermal capacity of aluminum cylinder. So what is the thermal capacity? So you got the specific heat capacity, thermal heat capacity. You can find it very easily. E is equal to ml. Okay, look at this question. Okay, for the first one, okay, the first one, you also can write the amount of heat required to rise the temperature of 1 kg unit mass. Okay, or you can write of substances by 1 Celsius. If you cannot remember this is also okay. If you cannot remember this, you can write this. The amount of heat required to rise temperature of 1 kg of substances by 1 Celsius. Okay, here now they are asking for thermal capacity. Okay, thermal capacity of aluminium. Okay, energy we know that is 8700, and so we have to calculate the C. So how we will calculate the this is the formula for a specific heat capacity. Okay, I'm asking about thermal heat capacity. Okay, thermal. So use this formula, E is equal to delta theta divided by delta theta. Okay, the energy is given, and change in temperature is, this is temperature. Okay, not time. Temperature is 12, so this is this much, 725 joule. Okay, now here they are asking again, I'm repeating it, say here. So see here, this is the formula for thermal heat capacity. Okay, write it in the notebook. Okay, this one is an explain a method of improving an accuracy. They are asking for improving an accuracy. What you will do? Obviously, you will put what lagging. Okay, and what else you can do? Reduce the temperature of, okay, reduce the temperature, or you can use lagging insulation. This is the most common one, using lagging and insulation. Okay, around the block or around this, what is given here, around this aluminium cylinder. What you write, use lagging or insulation around the aluminium cylinder. Wrap the aluminium cylinder with shiny material. Why? To reduce the thermal energy. This you can write. So again, I'm here you have to write this formula for thermal capacity, and specific heat capacity, for thermal heat capacity. This formula, write this one. Okay, to explain this is very easy. They are just asking state 2 way in which molecular structure of liquid differ from the molecular structure. This is not in this chapter. Explain in terms of energy the process which take place in solid at its melting point change in the liquid at the same temperature. So what happened when the in terms of energy the process which take place as solid and it at its melting point and change it to liquid? What happened when it change it to liquid? So when solid change into liquid, so what will happen? So first point, as I said you write energy. So first point you write energy is needed what to separate the molecule of solid, okay, or to break the bond. You can write to break the bond between the molecules. No need to write solid or liquid. So what you write first? A thermal energy or any energy or latent heat which is required to break the bond, okay, um, against the force of attraction between what? Between the molecules, okay. This you can write. See, when it is changing, so some then require the energy to break the bond, right? To break the this bond between the molecules and turn into liquid. So some energy they will require to separate the molecule first. So this point is very important. Even they sometimes they ask from what happened when it changed from uh, liquid to vapor and solid to liquid. So this is very important point, that energy is needed to separate the molecule against the force of attraction. Okay, this one, this is very easy question. Everything is given, mass is given, latent heat of fusion is given. So use the formula thermal energy E is equal to ml. So E is m is given, L is given, you can find the energy. Three. Okay, specific latent heat of fusion, just learn the definition, okay. Ice cube of mass is given in gram, okay. Mass is laminate mass is given 300 gram. So ice melt is this much, 23,500 joule, okay. Now the final temperature is 0. Calculate the specific heat of fusion of ice. They are talking what about the ice. So we will calculate. So what is the formula? E is equal to mLF, right? So I have to find the LF. So energy of ice is how much? This one, right? 23,500 joule. And what is the mass of the ice? The total mass was 70 gram. The total mass was what? Of ice. We are talking about ice, so you will find, don't take about laminate. They are not asking about laminate, okay. So it was 336 joule. So here now they are saying something about the specific capacity of laminate. Now we will take about laminate everything. So Q is to MC delta theta. So you have to find C, right? So Q is this one energy, thermal energy to melt the ice. This is okay. M is the mass of the what? Mass of the not of the ice, mass of the laminate. And temperature changes is 19, right? It's written here 19 it took. So now don't think why you are taking the this one, all the ice melted as why you're taking the energy of the ice. Okay, so when in the total, when it was the ice, how much ice was there? 700 gram. Okay, so how much drink they put? 300 gram. When they put 300 gram, right, all the ice melted. So how much energy? How much the total energy? This 23,500. So this is the thermal energy transfer from lemonade to ice. This, like suppose you are given this much energy. Suppose how much energy you have, you are giving to someone else. So that much energy she will have, right? She will have that much energy. Okay, this is the thing. So here they are saying all this much energy is transferred to laminate. Okay, this much energy is transferred from the laminate to the ice, from the laminate. So this is just nothing. This is the energy of both ice and laminate. You can take whether the ice is given to the laminate or laminate is given to ice, same amount of energy. That's why we are taking. So here read the sentence. This is very important. So, okay, the melting ice float on the top of the lemon. Explain the procedure. Okay, why it float? That I said you, when the density is less than the density of water, then it will float, right?